Okay, in this tutorial, we'll quickly learn how to create your own ATMEGA328, which we are using for the LED Lightbox project. But if you're watching this for some other project, this is still how you actually make a complete component from scratch in Fusion 360 Electronics. The first thing you're going to want to make sure you do is create your own electronics library. You can do that by coming up to the File menu and New Electronics Library. I'd give that a name, either your name, if it's something you're going to be using often, or if this is, it could be project specific, so something like LED Lightbox, but just something that you will know that you can find all the time. And it might also be helpful to maybe put AA in front of it so that it's at the top of a list alphabetically as well, but you don't have to do that. So go ahead and create your library. I've already done it, and if you can see here on the left, where is mine? Here it is. On the left here is my my library I've already created. I'm just going to open it up, and you can see what it kind of looks like. I'm going to try and open mine up. There we go. Okay, so now we're in my library. And I'm just going to move this thing here. We can open up our content manager, and you'll see I have some things here. In terms of making a component, there's kind of three parts to a component. There's the component's name, that's sort of like the title of something, of the object. And then if we look right here, we've got symbols, footprints, and packages. And the package is the 3D sort of model of something, whether it's an LED bulb or I don't know, headers. That's the 3D model. The footprint is actually the holes basically in the pads for soldering that will get generated on a PCB. And the symbol is for the schematic, what we're going to use for the schematic. So I've already created an ATMEGA328 here, but I'm just going to go ahead and walk through the process of creating a new one from scratch. So the first thing you're going to want to do is new component. So I'm just going to call mine ATMEGA328, and we'll do _2 since I've already made one. And I'm just going to click on OK. So here we can see it here. There's no little triangle next to it because nothing else is connected to it. This is just a title to contain a symbol, a footprint, and a 3D package. So why don't we go ahead and start with creating a symbol. I'm going to come over here to the symbols area, and you can see I've actually got a symbol already created, but we'll go ahead and create a new one. So we'll come up here, new symbol, and I'll just type in ATMEGA328, and again, -2. Click OK. Now I'm in the drawing area for creating a symbol. We'll start with our pins. And the ATMEGA has got 14 pins down one side. So I'm just going to put these in place here. There's 14. And I'm just going to switch the rotation here. Oops. Hold on here. Meant to switch this here. Now I can't rotate. Okay, let's see if I move this now. And I'm just copying it up. There we go. And we'll go all the way to 28 here. $27. And there's 28. All right, so we've got our pins. We can go ahead and rename these. And so in order to rename these, we know that this is pin 1, this is pin 14, this is pin 15, but they actually have kind of different names. This is the reset pin. We've got the crystal pins here. We're going to want to give them those names. So you may need to go find a diagram online of the ATMEGA328. It would probably look something like what I'm about to find here, like this. If I can just bring this over here, and we're looking at this, you can see that we're going to name these following this side here, reset digital pin, or I might put RX, so that you know what pin 1 actually does. Pin 1 is the reset pin. Pin number 2 is the RX pin. So we're going to go ahead and quickly rename those. You're going to want to bring this up on your own end to look at while you're doing this. So in order to rename these, I'm just going to click on the name, and then you can click here, and we can start to rename these. There's reset. We'll do RX. This will be TX. And what else we got? So now this is digital pin 2, DP2. DP3. And it really doesn't matter, just as long what we're naming is, it just matters that you know what they are and that they can correspond to the pin numbers. So this is 6 DP4. 7 VCC. It only lets you name a pin the same. It doesn't let you name pins the same thing. So we have 2 grounds. So I'm just going to say ground 1 here, and then ground 2 will be on the other side. Same here. I'm just going to call this CRY crystal 1, and this is crystal 2. Okay. And now DP5, DP6, DP7, and DP8. Now the spacing here on the grid doesn't really matter. Whoops, let me do this one. DP8. It will matter more when we do the footprints. DP9. All right, we're getting there. DP12. Whoops. Back here. DP12. DP13. And now, after DP13 is, we'll call this AVCC, AREF, ground 2, P23 is, these are analog inputs, so I'm just going to say AI0. And then analog inputs till the end, AI1, AI2, AI3, AI4, and AI5. All right, so we've got all our pins labeled here. Just so the schematic reads a little bit nicer, I'm going to add some lines around it here. Just grab that line tool. Just going around. like so. Click done. And I think I'm going to add some text. And we'll just call it ATMEGA328. And put that there. And hit done. All right, so now I've got a schematic symbol that reads with what the pins actually do. So we're done with that part for creating the symbol. Next, we'll move to the footprint. Again, I already got one here, but we'll go ahead and create one. So new footprint, ATMEGA328 -2. And here we are in the drawing area for footprints. I'm going to grab the pads here. Here, distance matters. So let's actually, I want that to be oval shaped. We're going to make this 60 and we're going to make this 40. This is specific for our PCB mill that we have here at the school. Now our grid is, each box is 0.05 inches. And then the standard between pin heads is 0.1 inches. So it'll be 2 boxes between the pads here. So we're going to do the same thing. I'm going to do 1 through 14 down one side and then 15 through 28 up the other end. Just like this. You can see that the number, pin number is populating in there. 8, 9, there's 10, 11, 12, 13, and there's 14. Now the distance in this direction also matters. I know that it's 0.3 inches, so we know that that's 0.1, 0.2, 0.3. And now I can just simply go back up. And if you get the distances wrong, you can certainly go back and change them at a later time. Not a big deal. All right, so there's those. Go ahead and save that real quick. And then we can also add some lines here just to make the silk screen that you would see on your PCB board. And I just want to also know which side is the top side. There's a little indentation. It's usually a semicircle, but I'm just going to draw a line because that's, or a rectangle here because that's way easier. And so that's the top of my ATMEGA. And I think I'll also add some text as well. And let's change the size of this to 35. Yeah. Perfect. So now that's what we'll see on the screen, on the PCB. So now I've created basically the title that's going to hold all the 3 parts of my component, the ATMEGA328. I've made a symbol for that ATMEGA328. I've made a footprint. And now there's a 3D model that we can make that will also go with it. So the component contains those 3 things. So what we can do here with our footprint is right click on it and create new 3D model. This will bring us to, we're just going to go ahead and save this. This is actually a regular Fusion 3D model, but it brings in the footprint and it's connected to that. So it could change if you wanted it to. It could update. The nice thing about this is Fusion has a package generator. So the package is the 3D part of these electronics. So I'll go ahead and click on that. We're going to choose the dip. And now we can go ahead and fill in this information that you see here. From my experience, this can be a little finicky. You'll have to do the best that you can. You can certainly find all this information online. Just search. dimensions of ATMEGA328, and you will find that. The first thing is we know there's 28 pins in it. These numbers I know are correct. This, the D number is not correct. I think it's 1.3. We're going to make that, and it's a 1.4. Do make sure that you're working, that if you're working in millimeters, you understand if you're working in millimeters or inches, those numbers will be quite different. So you just want to be aware of that. We'll see if that works. So we're just going to, I think this should work. Go ahead and click add. There we go. So now it's created the actual chip here. I'm just going to hit close. And I'm just going to jump on the top view here. And I'm going to use the move tool, making sure I select components. And I'm just going to kind of move this in place so that it aligns with my holes. And it's pretty good. You can see this distance is off. And there's, one of two reasons for that. One is my circuit, the pads are off, which is possible. The other is that the numbers I put in for the 3D model are off. Well, I don't know which is off, so I'm going to actually hit finish here. Just let that finish. And let's come back in here. This may be where I'm off. There's 1, there's 2, there's 3. Yeah, so this one's off. So what we can do is select all these. And let's move it 1 over. I can move this over, oops, like that. And let's see here. Can I move this? There we go. And let's move this just a little bit. Okay, I think that's probably fine. And open up my content manager again. Here's my 2. And, oops, that's for this. Let's come in here, double click on this, reopen it. And okay, there we go. Now you can see that it's updated and the hole placement looks a little more accurate to me. So I'm pretty happy with that. It may not be 100% perfect, but it's looking pretty good. And it'll be good enough for what we're trying to do. So I'm just going to hit finish. Hit save. Okay. So now I'm back in my library here. And if we go to the ATMEGA2 here, you'll see that there's no little triangle next to it. It just means that there's nothing in it right now. So I'm going to double click on it. Brings me to this white screen here. And the first thing I want to do is add my symbol to it, which we've already designed. So I'll hit add and look for ATMEGA2. Here's that symbol. We'll click OK. And I'm just going to bring it in and kind of center it on this. Like so. And done. Perfect. And so now we've got our symbol, and you can see now the little triangle has appeared here. And if I open it up, it's connected to that symbol. Move this up here. Maybe bring it here. The next thing we're going to do is kind of connect this symbol to the footprint in the 3D package we just created. So we'll go to New, Add Local Package, and let's expand this so we see which one we want here. ATMEGA2. Okay, and you click on OK. So that's kind of connected, but now we got to connect the pins. So here is where we connect the pins we labeled in the schematic, AREF, ground, RX, TX, VCC, to the numbered pins from the pads that we created. So looking at the diagram of the ATMEGA, if we just look at that again here, you'll see that pin 1 corresponds to reset. You'll see if we come down here, pin 19 is actually digital pin 13. So we want to come in here and sort of do that. So we'll click on digital pin 13 and look for pin 19 here. And then we will connect those. So you're just going to run through and connect all of those up. Once you do that, you'll hit OK, and then you'll be connected and you'll have a fully functioning component, ATMEGA component in Fusion 360, which can populate a schematic and then actually show up as a 3D model on a physical on a circuit board that you design in Fusion 360. I hope that helps. Let me know if you have any questions, and thank you for watching.